Now we shall move to the oscillators which are using the oscillator circuit with different components instead of using the L and C. As we have seen that the oscillators which are using L and C components in its oscillator circuit have drawbacks, certain drawbacks, as the waveform is not good and the instability in the frequency is there. Because of the instability of frequency, the waveform is not good, and on the other hand, they are not responding or they are not operated with the low frequencies. Therefore, to overcome these things, that is instability in the frequency and they are not operated for the low frequencies, so to obtain the good stable frequency, sustained oscillations, good waveforms, and to get the oscillator to be worked for the lower frequency also, we are now using the R and C components instead of using the L and C components in the oscillator circuit. So we shall say what are the RC oscillators. The oscillators using the components the RC oscillators. RC network. So this is simply using a capacitor C and a resistance R. So here the voltage applied across this input as VI, and the voltage which we are taking from this one is VO across the output. Okay, this is the resistance R and this is the capacitor C. A network having RC. Now, with the elementary engineering, that we have seen that a network which consists of C and R gives a phase shift. Normally, an ideal RC network gives a phase shift of 90 degree. But as we reduce the value of R to be 0, this network will give a phase shift of 90 degree. But reducing the value of this R to be 0 is impracticable, because if we reduce the value of this R to be 0, we will not find any voltage across this one. Therefore, it is impracticable to reduce the value of R to be 0. So, this value of R is to be adjusted in such a way that the phase shift obtained by this one should be adjusted to the phi is equal to 60 degree. Okay. So that the network 1 is to be cascaded to the another network, the second network is to be cascaded to the third network. So in this way, cascading the RC networks together, we will get a phase shift of 180 degree. If we cascade the 3 stages, okay, so we will get the one network will give you 60 degree, the second will give you another 60 degree, and third will give you another 60 degree, so that we will get a phase shift of total phase shift of 180 degree. And the condition, what we call as the Bar-Christian's criteria, is to be satisfied by just using the cascade of 3 networks together. So that the 180 degree phase shift is to be obtained by this RC network, and another 180 degree phase shift is obtained by the transistor properties, so that whatever the energy which is fed back to the tank circuit or to the oscillator circuit will be in phase, so as to overcome the losses which are to be in the tank circuit. Okay, so that to obtain the sustained oscillations, and to satisfy the Bar-Christian's criteria, we will get the phase shift is a correct phase shift, and the feedback which is to be given to the tank circuit will be in phase. In this way, that is, the RC network is to be used instead of using L and C. Now here the inductors are not used. Okay, inductors are not used. Only having the simple components at C and R, we will get the phase shift of 60 degrees and 60 degree and 60 degrees, so that 180 degree phase shift is obtained by the this one. In case of LC oscillators, we were obtaining the phase shift of 180 degree by either the coupling of the inductors or coupling of the capacitors. Okay, now the same 180 degree phase shift is to be obtained by using, and the frequency of operation for such one is to be given as, that is, this is totally dependent upon the values of R and C. Therefore, it is to be given as 1 upon 2 pi R and C under root of 2 into n, which the n stands for the number of stages. If you have 3 stages, so this will be 3 into